Hey guys, welcome back to my channel. Myself Shiv Prasad. I hope you are all doing great. If you are new to my channel, don't forget to subscribe and don't forget to tap the bell icon so that you won't miss any updates from my end. In this lecture, we are going to understand about what is sliding window algorithm and what its significance while solving a problem. Let's try to understand what does it mean by sliding window algorithm. So basically sliding window algorithm, okay, as name saying like it's an algorithm, so we need to follow some sort of steps to solve a problem. But why exactly the name sliding window? So basically we might see the problem like subarrays, substrings, etc. Right? So these are all like range based problems. Range based problems. So when we are trying to solve these kind of problems, okay, so we people always tend to fall in big O of n square or big O of n cube time complexities. Okay, so sliding window algorithm, okay, will try to help this kind of time complexities to big O of 1. Okay, it's a kind of an optimization. Okay, let's try to understand in real. Let's assume we are given one input array, something like 1, 2, 4, 6, 7, 8, 9. Okay, there are total 7 elements. And we are given a target k equal to 3. This is array. So the ultimate goal of this problem is you need to find sum of k elements and return the maximum. Okay, sum of k subarrays. Let's see. K is 3, so this is one subarray. What is the sum? 1 plus 2 plus 4. This is nothing but 7. And then this is one subarray, 2 plus 4 plus 6, which returns us 12. And this is one more subarray, 4 plus 6 plus 7, 17. And this is one more subarray, 7 plus 8, 15 plus 6, 21. And this is one more subarray, 7 plus 8, 15, 15 plus 9, 24. And if you carefully observe, these are my sums, right, of given k size elements 17, 21, and 24. What is the maximum here? 24, right? So we need to return 24. So if you look at this problem, so generally what we take, so first we take an outer loop. So for I equals 0, I less than n minus k, and I plus plus. Okay, instead that we take an inner loop for j equal to I, j less than I plus k, j plus plus. Okay, and we do all the sum from 0 to, I mean from I to less than I plus k, and after this we take the max. Okay, max is equal, let's assume like in inner loop we are having this variable called current max, but outer we have something called max. So max is equals to math dot max of max comma current max. This max is so far max. This current max is of given size k. Okay, the particular subarray. So this is how we generally take a problem, right? So if you carefully observe what is the time complexity. So this outer loop will take big O of n, and this inner loop will take big O of k, where k is the size. So basically it is nothing but big O of k into n, right? So can we optimize this problem from this to big O of n? Yes, that is possible with the help of sliding window algorithm. So basically, if we would like to understand the sliding window algorithm, so this algorithm applies on range based problems. Okay, range based problems. Okay, whether it may be subarray or a substring. Okay, and this will help us to reduce the time complexity from big O of n squared to big O of n or else n cube to n. Okay, so basically the nested loops, okay, nested loops will be reduced to single loop. Okay, single loop. So these are, I mean, this particular algorithm applies on finding the minimum or maximum of subarray size k, subarray size k, or else finding the longest or else smallest substring, or else subarray, depending upon the condition. Okay, example, I have string called A, B, C, D, E, A, B, X, Y, Z, P, Q, R. Okay, let's assume this is my input array. So what I need is I need to find the longest subarray with unique characters. So what is the unique character? So A, B, C, D, E. This is one subarray of size 5. Then I have B, C, D, E, A. This is another substring of size 5 again. Then I have C, D, E, A, B, X, Y, Z. This is complete one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we written 11. Okay. So this is all about the sliding window algorithm. So now let's try to understand the types of sliding window algorithms. Types. So basically these are fixed size sliding window algorithm, and then flexible size, flexible, or we can call dynamic size sliding window algorithm. Okay, sliding window technique or else algorithm, whatever you can name it. So when we say fixed size, okay, so the window size is going to be fixed. Okay, in previous example we given an input array, we given k, right? Here we know k, so inside this array we need to find the maximum sum of k elements. Okay, subarray k elements. So here we know k, that's the reason it's fixed. So sometimes we will be given only input array and we need to find maximum sum of subarray, okay, where we don't know k. Okay, so we need to still we need to find it. So that is going to be dynamic size. Okay. And by the way, let's try to understand what is term mean by window. Okay, we are keep on talking about sliding window, right? So let's try to understand what is mean by this sliding, what is mean by this window. Let's understand with an example. Okay, I given an input array like 1, 2, 3, 5, 6, 7, 8, 4, 0. Let's assume this is my input array and I given a k as 3. So what I said initially, we with an array approach we need big O of k into n time complexity to solve this problem, right? Because where k is for inner loop and n is for outer loop. And now we would like to reduce the time complexity, as I said, from big O of k into n to big O of n. So basically sliding window is nothing but the word slide means, as you can see in basic term, like you need to slide. I mean, you need to shift, right? Either to left to right. Okay. And window is nothing but this K. I mean, window is nothing but range. If I would like to precise, window is nothing but range. Okay. From example I to J. Okay. This is a range. So now let's try to understand this. So first subarray is this. Okay. The sum is 6. Now what I'm going to do is I'm just going to slide this window by one position. When I say one position, okay, when I say one position, this particular one, okay, now will start from here and will end at here. Just I'm sliding one position. Okay, so that I can get another subarray whose sum is going to be 10. Okay, and once I get this, again I'm going to slide this one, right? So I'm going to slide this by one position again. Then this time I'm going to get sum of 3 plus 5, 8 plus 6, 14. And I'm done with this subarray. Then again I'm going to slide one position, and every time I'm maintaining a window of size k. That also we need to ensure in this problem. We should always maintain a window of size k, along with we should able to slide by one position. Okay, so now 5 plus 6 is 11 plus 7 is 18, and again I'm sliding by one position. Every time I'm sliding by one position and I'm maintaining the size of window, so it goes so on. So this is mean by sliding window. So when you are approaching this method, okay, algorithm, you are going to iterate through this complete array only once. Okay, you are not going to use a nested loop. So that's a reason this will take big of n time complexity. I hope you got the significance of sliding window algorithm, and in subsequent lectures I'm going to post a beautiful and quality problems on this algorithm for given two types. When I say two types, fixed size based, dynamic size based. That's all for this video. If you like this video, please do subscribe and don't forget to tap the bell icon, and please do encourage. Thanks a lot. I will meet you.